Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Encoder-Decoder Models. Understanding AI's translation and summarization powers. Imagine an AI that can instantly translate any language or condense a huge article into a few sentences. That's not magic. It's the power of encoder-decoder models. In this lesson, we'll break down how these amazing AI tools work, making complex tasks like translation and summarization possible. No prior AI knowledge needed, we'll build it from the ground up. For us, a sentence like, "I love AI," makes sense because we understand the order of words. But for a computer, words are just data points. How do you teach a computer to understand not just individual words, but the asterisk meaning of a whole sentence, where word order is crucial? This is especially tricky when the input and output aren't the same length or structure. Like translating hello to hola. Let's imagine you're a UN delegate, and you need to translate a speech from Japanese to English. You don't just have one person doing it. Instead, you have two experts. One, the interpreter, the encoder. This person listens to the asterisk entire Japanese speech, understands its core meaning, and then summarizes it internally, maybe as a set of key ideas or emotions, without actually speaking English yet. 2. The storyteller, the decoder. This person then takes those summarized key ideas from the interpreter and reconstructs them into a beautiful, fluent English speech. This two-step process is exactly how our AI models work. Think of the encoder as the listening part of our AI. When you feed it a sentence, like bonjour, comment caviar, single quote, the encoder's job is to read every word, understand its context, and then compress all that meaning into a special, compact thought vector or context vector. Developers view this vector is just a long list of numbers. Each number represents some aspect of the input sentence's meaning. It's like distilling a complex idea into a single, rich data point that captures its essence. Ready for the next step. Now, once the encoder has created that thought vector, our summarized meaning, it passes it over to the decoder. The decoder is the speaking part. It takes this distilled meaning and, word by word, starts generating the output sentence. Developers view the decoder doesn't just guess. It uses the thought vector as its guide and predicts the asterisk next most likely word to create a coherent sentence. It's like a smart autocomplete, but powered by the full understanding of the input. So, the whole process looks like this. 1. Input, e.g., French sentence. Asterisk goes into the asterisk encoder. 2. The asterisk encoder asterisk processes it and creates a meaningful thought vector. 3. This thought vector is passed to the asterisk decoder. 4. The asterisk decoder asterisk uses this vector to generate the asterisk output, e.g., English sentence. Word by word. This architecture allows AI to handle inputs and outputs of different lengths and structures, which is crucial for tasks like translation and summarization. Encoder-decoder models are the foundation for many amazing AI applications you use every day. Machine translation. Think Google Translate, DeepL. They take a sentence in one language and produce it in another. Text summarization. Tools that can read a long article and give you the key points. Chatbots. Older versions. Some earlier chatbots use this to understand your question and generate an answer. Code generation. Simplified. In some contexts, you could imagine an encoder understanding your natural language request, and a decoder generating code. As a developer, understanding encoder-decoder models means you're grasping a fundamental building block of modern AI. You might not build one from scratch, but you'll use libraries and APIs that leverage them. Think about it. You could integrate a summarization API into your app, or use a translation service to make your product global. Knowing how these black boxes generally work empowers you to use them more effectively, debug issues, and even imagine new applications. This is your entry point to building intelligent features. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.